Hello everyone, welcome back to our YouTube channel. Now in this video, we are going to talk about mixture. So we'll take some questions on mixture. Now to start with, mixture is a nothing different topic. The mixture questions are basically the real life application of percentage and ratio type questions, which we have already discussed in previous videos. Now in CAT, mixture is fairly common. You may expect one question in every slot of CAT. And now mixture questions are sometimes very simple. Sometimes they follow certain logical abilities or logical process. And sometimes they follow certain pattern or formula. So in this video, we are going to discuss all these types of questions. Okay. Now to start with, what's the definition of mixture? So as you all understand, the mixture means when you mix two or more different things to produce a common or a mixed product. For example, when you mix water with milk, it becomes a mixture. Okay. When you mix water with wine or any other thing, or you may mix one variety of rice to another variety of rice, then also it becomes a mixture. Okay, so these are basic definition, but the questions mainly involve the application of ratio or percentage. So let's check out a simple question first. To start with a simple CAT question that appeared in 22. It says, a mixture contains lemon juice and sugar syrup in equal proportion. If a new mixture is created by adding this mixture and sugar syrup in the ratio 1:3, then the ratio of lemon juice and sugar syrup in the new mixture is what? Yeah, quite common, quite a straightforward question. So if I draw the schematic for you, the first one, it says the mixture contains, so this is a beaker or a vessel. So this contains lemon juice and sugar in the equal proportion, means 1:1. Now a new mixture is created by adding this mixture with pure sugar syrup. Okay, pure sugar syrup, which is S, in the ratio 1:3. Then what will be the proportion of, if I mix these two, then what's the proportion of, final proportion of lemon and sugar syrup? Okay. So quite simple. So let's assume I take 1 liter of this solution. 1 liter of this mixture of lemon and sugar. 1:3, let's take 1 liter. So if I take 1 liter of this, so what will the quantity of lemon in this? It's 1:1. That means half liter will be lemon and remaining half liter will be sugar syrup. So sugar syrup will also be half liter. And here I will find pure sugar syrup of 3 liters. So now if I mix them together, what is the quantity of lemon? So lemon syrup will remain as half, but sugar syrup will be what? Half plus 3, which is 7/2. So what is the final ratio of lemon and sugar syrup? That is simply half is to 7/2, which is simply 1:7. So the question is as simple as that. So it is only testing our general application of ratio or general ability or ratio. Fine. Let's take another example. Now here we'll be doing intermixing of the mixtures. Now this is an interesting question. Let's see what it says. So it says a glass contains 500 cc of milk and a cup contains 500 cc of water. From the glass, 150 cc of milk is transferred to the cup and mixed thoroughly. Next, 150 cc of this mixture is transferred from the cup to the glass. Now the amount of water in the glass and the amount of milk in the cup are in the ratio of what? So twice intermixing is happening. Seems confusing or tedious, but it is not if you apply your logic. Now, if I draw the schematic, it will be better for our understanding. Okay. So first one is, this is the glass. Let's take this is the glass. So this contains 500 cc of milk. And this one is a cup. And this contains equal volume of water as per the question. Now what happened first? So first you take out 150 cc from here. Okay. So you take out 150 cc of milk and mix it here. Okay. Then it becomes a solution of water and milk. Next, again you take out 150 cc of this mixture, right? And then it again becomes a solution of milk and water. Now, the important thing to notice is that, and in the end, both the beakers have equal volume of solution. This is also a 500 cc, and this also remains 500 cc. The total volume of the beakers or the vessels are remaining same or fixed. Okay. Now I have to find amount of water in the glass, right? So I have to find the amount of water here, right? I have to find the amount of water here, and I have to find water of milk in the cup. This ratio I have to figure out. So if you go by simple process of ratio, then it will be lengthy. But what you can do here, if we apply logic here, what you can do? So first, so this is the milk. Now think logically. Let's take after this intermixing, okay? In the glass, there is excess of milk, okay? In the glass, we have excess of milk. So what will happen? What is the remaining? That means in the cup, there will be remaining 500x minus or 500 minus excess of milk in the glass or in the cup. Okay, so what I am saying, so overall there was 500 cc of milk initially. So let's take the glass contains now, after intermixing twice, the glass contains excess of milk. That means remaining 500 minus excess of milk must be there in the cup automatically, because total volume is fixed in both the glass and cup. Therefore, now if you talk about water, what you can say? The glass contains excess of milk. That means remaining 500 minus xcc will be water automatically, because total volume is fixed 500 cc. And out of 500 cc, if x is milk, the remaining 500 minus x must be water. On the other hand, this cup contains, the cup total volume is again 500 cc, okay, and it contains 500 x minus of milk. So automatically it will contain x cc of water, right? Because total volumes is fixed. Now what they want? I want amount of water in the glass. So what is the amount of water in the glass? Which is 500 minus x. And amount of milk in the cup. Amount of milk in the cup is 500 minus x. That means they are in equal proportion. So 500x minus x into is to 500x minus x. It will ratio will be same, or 1 is to 1. Right? So basically you do not need any calculations if you apply this logic. And the logic is simple. Why it is 1 is to 1? That is because the volume of solution or volume of mixture in both the beaker or in both the glass and the cup are remaining same. That is 500, 500. So even if you intermix it 4 times, 5 times, if you take out 150 again you 150, 150, if you keep transferring like this for n number of times, even at the end, the ratio of water in the glass and the ratio of milk in the cup will remain 1 is to 1. You can check out. It will remain 1 is to 1. If the total volume of mixture in the glass and cup remains 500 at the end, the total volume will remain 1 is to 1. Okay. So even if you continue this for 10 times, intermix it 10 times, the volume will or answer will remain as 1 is to 1 only. Fine. So next, now we take another question, this type of logical question. This appeared in CAT 22 slot 3. Now it says, there are 2 containers of the same volume. The first container half filled with sugar syrup and the second container half filled with milk, half filled. Half the content of the first container is transferred to the second container, and then half of the mixture is transferred back to the first container. Next, half the content of the first container is transferred back to the second container. Then the ratio of the sugar syrup and milk in the second container is what? Now mind it, in this case, half is transferred. Again, half of the second beaker is transferred. That means in this case, the volumes are not being fixed. So at the end, volume of mixture in both the beaker and in both the vessels are not going to be equal. So in this case, we cannot apply the previous logic of 1:1. Right? So in this case, we have to go by step. So what step we will follow? So what you do here? So again, if we draw the schematic, it will be easier for us to calculate. Okay. So again, if we draw the schematic first, so now first what I do, it is half filled. So instead of taking half, let's take a number. Now what number should I take? Half filled. Now you see you are transferring the contents half of the contents thrice, right? So thrice means half into half into half, which means 1/8, right? That means let's take the total or initial volume as something multiple of 8. That will help our calculation because half is being transferred thrice. So we take the total volume or the initial volume as something multiple of 8. The multiple of 8, what should I take? I can take it as 80. Let's take 80 or 160. So let's take initial volume was 80 cc. So in both the beakers or both the vessels, initial volume was 80 cc. This is the first one. First container half filled with sugar syrup. So this is sugar. And the second is contained filled with milk. So each has now 80 cc to start with. Why 80? As I told you, because you are transferring it, the contents thrice over. So thrice over means half into half into half, 1/8. So that's why I've taken the initial value as something divisible by 8, which is 80 or 160. Okay, so this is the initial situation or initial position. Now what happened after the first? After the first step, what will happen? So after the first step, what will happen? Now it says half the content of the first is transferred to the second. Fine. So first initially I have sugar syrup 80. Now it will become what? Now sugar will come to 40. Sugar will become 40 cc. And here what will happen? So milk will remain 80. Okay. So milk will remain 80. And now sugar will come here as 40. Now it will become a mixture of sugar and milk, 40 and 80, or in the ratio 1:2. Right? So fine. Now second step. So if I draw the same, what will happen? And then half of this mixture is transferred back to the first. Okay. Transferred back to the first. Now what will happen? If I take out half of this mixture, right, then what will happen? That means half of sugar and half of milk will also be shifted, right? They will move in the equal proportion. Okay. So what will happen then? What will the amount of sugar here? So here sugar is what? 40. Sugar was 40. That means now sugar will be left here 20. So 20 will be shifted here. That means now sugar will become 40 plus 20, which is sugar will be now 60 here. Okay. And milk, again, half of milk will also be shifted. So milk is 40. Milk will be remaining 40. So remaining 40 will shift to the first beaker. This we can say. Right? So when you take out half of this, which means half of every component will also shift or in equal ratio. That's the simple logic. Now what will happen after the third step? If I draw it here, third step. Now it says half the content of the first container is transferred back to the second container. Again, half the content of this is transferred back. So what we can say in this case? Again, half of this will transferred back. So what will happen now? That means again, half of each of the component will be shifted to the second container. So now what will happen? So now sugar is 60. So now sugar will be left as 30. Right? So how much will be sugar here then? 20 plus 30. So now sugar will be 50 here. Then for milk, milk was here 40. Now half will be transferred. So remaining will be 20. So how much will be transferred in case of milk? It was 40. Now 20 will come here. It will become 60. So this will be the situation. Yeah, simple. The simple logic is when you take out half, that means half of each component will also shift out. Now what they ask? Ratio of sugar syrup and milk in the second container. So what's the ratio of sugar syrup and milk in the second container? So sugar syrup is to milk will be what? That would be 50 is to 60 or 5 is to 6. So option 1 is my simple answer. So the question seems complicated or very clumsy, but if you apply your basic logic, you can go home very fast or conveniently. Okay. Now we do a simple one repetition of mixture-based questions. Now in this case, we are repetitive mixing that we say is a certain pattern of question. And the pattern is the simple is this. So there is a vessel. Let's take this contains initially X liters of spirit. So it has fully spirit, X liter of spirit. Now from this, if I take out Y liters, so I'm taking out Y liters of spirit. Okay, and it is replaced by some quantity of same quantity of water. So I'm mixing at Y liter of water. Again, I repeat the process. I take out the Y liter of the solution and replace it by Y liter of water. Again, I do the same thing. So what will happen in the final solution? So finally, amount of spirit left in the container divided by original quantity of spirit. That will be equal to total amount of spirit minus quantity drawn divided by total mixture, or in general x minus y by x whole to the power n. So this is a particular situation that you can remember for this type of repetitive mixing for this particular situation, because this type of questions are quite common in CAT. So we can take a latest example in CAT 24, where you found a similar question and quite straightforward question that appeared. So it says a glass is filled with milk, 2/3 of its content is poured out and replaced with water. If this process of pouring out 2/3 content and replacing with water is repeated 3 more times, then the final ratio of milk to water is what? So again, it's a repetition of the same mixture, repetitive mixing. So what I can say here, 2/3 is there. Na? So let's take initially, there was 3 liters of milk. Okay. Initially, there was 3 liters of milk. Let's assume that. Now, 2/3 means what? So 2/3 of 3 means simply you are taking out 2 liters. So that means let's take y equal to 2 liters of milk is taken out and replaced by 2 liters of water. And this process carried out over 3 times more, which means what? Total it is done 4 times. So what will happen? So I can say that the amount of milk left. So I can say here that amount of milk left, if I apply the same logic, upon initial amount of solution or initial amount of milk, because initially it was pure milk, and that would be equal to x minus y by x whole to the power 4 here. Okay. So what I can say here, x equal to 3 minus 2 by 3 whole to the power 4, right? So what's the amount of milk left? By initial amount. What's the fraction? That means in other words, what is the fraction of milk left? That would be equal to what? So 1 minus 3 whole to the power 4, which is equal to 1 upon 81. That means what? The fraction of milk left is 1 upon 81. Which means if I say now, that means if the initial amount of milk was 81, what is the milk left now? So how much is the milk left? After the fourth process, milk left is now only 1 liter. If initial was 81 liter, milk left is now 1 liter. That means remaining must be water. So what is the amount of water left? That is 80 liters. So now it's very simple. Now the question says, what is the final ratio of milk to water? So what is the final ratio of milk to water? Which is simply 1:80, or option D. So these are our typical questions on mixtures, where they ask you simply basic level understanding or a certain pattern based questions. So if you practice this type of questions, then you're sure to do well in CAT for mixture related questions. So with this, I am signing off. I'll see you next in the next video with some other topic.